table, and or any place, and you see it's beeping. What is that? Most of that is radiation coming from outer space. Cosmic rays, most of cosmic rays are protons. They smash into the Earth's atmosphere and produce muons. Most of this stuff is muons that are coming down through this counter. Okay? So we're being irradiated all the time. What do those muons do? They can create ionizing radiation. There's background radiation. There are slight amounts of radioactivity in this tabletop. But most of it's coming from outer space or from our atmosphere. Now, what happens when we look at things that are radioactive? This watch was painted with paint that would fluoresce when struck by radiation. Actually, tritium was used. Tritium is a radioactive isotope of hydrogen. That's what radiation that is not background is like, okay? Way more significant. So background radiation is around all the time, not much we can do about it. And it's relatively low level. There's a mantle from a camping lantern. This is one that would be a replacement mantle. It's radioactive. There's a bunch of stuff around that you can find. These are the more common things. Okay. By the way, glowing watch dials now do not use tritium. You've got to find really an old one. Anybody have Fiesta ware? Orange? Okay. Pretty radioactive, okay? That orange color comes from an oxide of uranium. Okay? So the glaze is what is radioactive about that. Here, smoke detectors. Most of us have these, or if you don't, you should. Smoke detectors actually have a man-made element that's radioactive called americium. It has a higher atomic number than 92. It's quite radioactive. It's how the detector actually does its job and detects smoke particles. I won't go into the details. Now, those are probably the more interesting ones. Here are some radioactive elements. There's a little piece of material buried in this big chunk of plastic. Strontium-90. Strontium-90 is a beta source. Fairly radioactive. But beta particles, here we have a piece of aluminum. What time is it? Oh, we're running out of time. Here's a piece of aluminum. Put that over there. Now that's better. Let's get about 3 pieces of aluminum. We've pretty much blocked and shielded ourselves from beta radiation with a few sheets of aluminum, okay? You might say, oh boy, then I can buy a suit like that, and if there's ever a nuclear war, I won't be killed by the fallout because I can wear my special suit. Except, unfortunately, there is gamma radiation. Gamma radiation is cobalt-60. Cobalt-60 is used in radiation therapy in hospitals. Here we have lead. Imagine wearing a lead suit. You couldn't even walk. And by the way, I got to show you how active it is. This particular sample is old and it's not very active, but it's highly penetrating. See, that's faster than background. Okay. And now I'm going to put this amount of lead, and that's still more than background. and I'm considerably further away besides. So this amount of lead doesn't do you any good at all with gamma. There are different intensity of gamma rays, and so pretty much you can't protect yourself. The only way you can protect yourself is to not have a nuclear war or anywhere near where a nuclear war takes place. Okay? So.